we have a linear transformation from vector space V to vector space W, and both the vector space is over the field F. Okay, and it is a linear transformation, and T is invertible, means it is 1 1 and 1 2. Then we have to show that T inverse is also a linear transformation. ओके, सो हम लोग को एक लीनियर ट्रांसफॉर्मेशन दिया गया है जो वेक्टर स्पेस V से वेक्टर स्पेस W पर है, एंड वह इन्वर्टिबल है, मींस 1 1 भी होगा एंड ऑन टू भी होगा. देन T इनवर्स जो भी मिलेगा हम लोग को वह फंक्शन क्या होगा, एक लीनियर ट्रांसफॉर्मेशन मिलेगा. ये हम लोग को प्रूव करना है. ओके, सो फर्स्टली to show T inverse of W1 plus W2, what we know that T is a linear transformation from V to W. So how T inverse will look like? T inverse will be W to V, and it is a linear transformation from W to V. So we have taken two elements from W1 and W2. So firstly we have to show T inverse of W1 plus W2 equal to T inverse of W1 plus T inverse of W2, where W1 and W2 both are from vector space W. Okay, we no need to show this since T is 1 1 and on to. We have given that T is 1 1 and on to. So for any W belongs to vector space W, for any element, okay, so we should have preimage because of T is on to, and because of 1 1 we should have a unique preimage. Okay, so for any W there will be unique V. Okay, because of 1 1 and on to, because of on to we have a preimage, and because of 1 1 we have a unique preimage. Okay, there will be unique preimage V such that T of V equal to W. Okay, so using the condition that T is 1 1 and on to, we have found that we will always have a unique preimage for any element of W. Okay, now let W1 comma W2 are from capital W, means it is the arbitrary element of vector space W. So हम लोग को शो क्या करना है, हम लोग को शो करना है T of V, what we have written here, T inverse of W1 plus W2 equal to T inverse of W1 plus T inverse of W2. So हम लोग जानते हैं कि for any element of W, we have a unique V. So let V1 and V2 be two element from capital V such that, okay, so we have a T from V to W, so we have a V1 whose image is W1, okay, and we have a V2 whose image is W2. okay, so we have assumed हम लोग के पास दो वेक्टर है कैपिटल V वेक्टर स्पेस में, जिसका इमेज W1 and W2 है. So what we need to show here, T inverse of W1 plus W2 equal to T inverse of W1 plus T inverse of W2. Now take RHS. Okay, so T inverse of W1 plus T inverse of W2 equal to what we got from here, that T inverse of W1 equal to V1, because T is 1 1 and 1 2. We have pre-image of W1 is V1, and T inverse of W2 equal to V2. So now we can put here, because T inverse W1 का value V1 है, तो we can write here V1, and T inverse W2 का value V2 है, तो we can write here V2. Okay. Now because this is an element of capital vector space B, T inverse W means T inverse is a function from W to V. So image element will be in V. So this is element of V. This will also be element of V. Okay, that's why it can be equal. So now for any element of V, we can operate T linear transformation. Okay, so taking T on both side, we get what we get here, T of T inverse of W1 plus T inverse W2 equal to T of V1 plus V2. Okay, because this is equal and T is 1 1, because of T is 1 1, their image will be equal. Okay, due to 1 1. And now due to linearity of T, we have T of V1 plus T of V2. And also we know that T of V1 is nothing but W1 and it is W2. So we can write here W1 plus W2. This will imply T of T inverse of W1 plus T inverse of W2 equal to W1 plus W2. Now since T is 1 1 and onto, so T inverse will also be 1 1 and onto. So since this is element of W, this is element of W, and since this is element of V, and when we operate T, the element of V, we get the element of W. So whole is the element of W. So for any element of W, we can take a T inverse operation, T inverse, okay, T inverse function. So this will be equal to what we will get here, T inverse of W1 plus T inverse of W2 equal to T inverse of W1 plus T W2. Okay, because T inverse and T will be identity. So what we got here, T inverse of W1 plus T inverse of W2. Okay, so first part we have proved that T inverse of W1 plus T inverse W2 equal to T inverse of W1 plus W. Now for lambda belongs to field and W belongs to capital W, we need to show what we need to show is that T inverse lambda W should be equal to lambda T inverse W. Okay, or for any W belongs to capital W. We need to show this one. How we will prove? Okay, so let RHS. RHS has lambda T inverse W. So we can write here, we can write here, we have a unique preimage for any W. So we can write here, this is nothing but lambda of V. Okay, because if we assume, let V belongs to capital V such that T of V equal to W, so this will imply T inverse of W equal to V, because T is 1 1 and 1 2. So this is now taking T on both side. Okay, since this is element of capital V vector space and this is also an element of vector space B, because T inverse is a functions from W to V, so image part will be in V. So we can take T because T is a functions from V to W. Okay, so we can have T of lambda T inverse W will be equal to T of lambda V, and since T is linear we can have lambda T of V because properties of linearity, and we can write here lambda and T of V, we can write here W. Now again taking T inverse on both sides, what we get, T inverse, T will be identity, so we will get lambda T inverse W equal to T inverse, we have taken T inverse on both sides, so lambda W. And what we need to prove? Okay, T inverse lambda W equal to lambda T inverse W. And say T inverse is also a linear transformation. Okay, so thank you for watching this video, and if you like this video, please like and subscribe my channel. Thank you.